Continuing with this example, I want to determine which of the following pairs of statements are equivalent. Here, the pairs of statements say, if Britney Spears is the greatest singer ever, then I'll eat my shorts. The second one says, if I don't eat my shorts, then Britney Spears is not the greatest singer ever. If I call Britney Spears is the greatest singer ever P, and I'll eat my shorts Q, this first statement can be written as if P then Q. Looking at the second statement then, I don't eat my shorts should be the negation of Q. Britney Spears is not the greatest singer ever should be the negation of P. And I should see that this argument is structured as if not Q, then not P. The relationship between these two statements, the original conditional and this one here, this is a contrapositive relationship, and we know contrapositives are equivalent to conditionals, so these are equivalent. Continuing with this example, let's compare these two statements. If I buy a ski boat, then I will not buy a triathlon bike. I want to compare that to the statement, if I don't buy a ski boat, then I'll buy a triathlon bike. Looking at this first statement, I can write this as, with P as I buy a ski boat, and not Q as I will not buy a triathlon bike. This looks like if P, then not Q. Look at the second statement, if I don't buy a ski boat, that's the negation of P, then I'll buy a triathlon bike. That would be relative to the negation of Q. Over here, this should be just Q. So the relationship I see in number 2 is if not P, then Q. Now this doesn't seem to fit identically with what we saw before, the relationships we started with, but let's break this down a little bit. This is a conditional. I start with if the first thing, then the second thing. This is a related conditional and it involves only these two statements. In particular, when I go from P to not P, I've negated that. When I go from not Q to not Q, I've negated that. That's what I'm doing to get from this to this. The order was preserved, but each part of it was negated. That relationship, if you look back in your notes, describes the inverse relationship. These are indeed inverses of each other. Now the question here was to determine which of the following statements are equivalent pairs of statements. These two statements are inverses of each other. Inverse statements are not equivalent to each other. So the answer to the question here should be that these are not equivalent. Recognizing that they're inverses allows us to see that they are not equivalent statements. In this example, the two statements we're looking at are, if a student studies hard and does the homework, then the student will pass, along with the statement, if the student did not pass, then the student did not study hard or did not do the homework. To break this down, let's pull out the parts we need to see. The student studies hard, let's call that P. Student does the homework, let's call that Q. The student will pass, let's call that R. We do see there are 3 parts to this. The second statement, if the student did not pass, well, we just called the student will pass R, so this would be the negation of R. Then the student did not study hard, well, that would be the negation of P. And lastly, we see did not do the homework, that would be the negation of Q. Putting this together, we can break that first statement up as P and Q, that is, if P and Q, then R. The second statement should be, if R, then the negation of P or the negation of Q. And those are the two statements I want to compare. Let's try that one more time. There should be the negation of R here. The negation of R, if the negation of R, then not P or not Q. Continuing with this, we see that what we really want to compare are these two relationships. Since our goal is to determine if these are equivalent, we're really trying to, and these are conditionals, we really want to determine if this is a contrapositive relationship. To add some clarity to how we're going to go from here, let's review the contrapositive relationship. Again, it was structured as if P then Q is equivalent to if not Q then not P. Now, important to this discussion will be the fact that P and Q aren't very important that it's P and Q per se. It is very important that I keep this relationship. That is, this first thing, let's call it star, goes here. If star goes here, then star goes there. All right, that's the relationship we need to see. We'll call this happy face. If happy face goes where Q is, then happy face goes down here where Q is. This relationship has to hold. If star then happy face is equivalent to the relationship if not happy face then not star. And that's what we need to see to determine whether or not this is equivalent. In particular, we're really asking the question, is this thing here, well, let's call it star, the negation of this thing here? Is this thing here, let's call it happy face, the negation of this thing here? Well, looking at that, the happy faces look good. That relationship seems pretty clear. Let's examine the statement P and Q relative to the statement not P or not Q a little further though. Thinking about this for a second, the only relationship we've talked about that could relate these two things was De Morgan's law. In particular, it said, part of it said, that the negation of P and Q is equivalent to the negation of P or the negation of Q. Looking at what I have here, I see that matches part of what De Morgan's laws say. And in fact, that the negation of this part right here, the negation of P and Q, is indeed what I have over here. So this relationship of if star then happy face versus if not happy face then not star is the relationship I see in this problem. So D was the problem we were doing here. D showed a pair of statements that are equivalent. You may want to review this last example as it goes through a lot of what we've done in the last couple of videos, and have fun with logic.